Okay, so in this video we're going to continue the discussion of relative risk, but we're going to talk about how to use the 2 by 2 table, which is the most common way of calculating relative risk. So here we are with our population of 20 people, some of whom are smokers and some are non-smokers. So the smokers are the exposed group, so we're looking at the exposure of smoking as it relates to heart disease. So the heart disease is our outcome. And so some of these people have heart disease and some do not. So let's see how to put these different groups of people into the 2 by 2 table in order to calculate relative risk. Okay, so here's the 2 by 2 table, and what you can see is that the table is set up with the exposed in the first row, unexposed in the second row, disease, people with the disease in the first column, and people without the disease in the second column. And so it's always set up in the same way. That is, disease is always in the first column, no disease in the second, exposure in the first column, unexposed in the second column. And each of the cells is labeled. So the cells are labeled A, B, C, and D. All right, and then the formula for relative risk is shown using those letters. So now we're going to take all these people. These are our people that are 20 people from the last slide, and these are the people in our population, and we're going to calculate the relative risk of smoking for heart disease among these people. So we're going to put them in their respective cells. So here's the table filled in. So what we see here is for our population, we are looking at smoking as the exposure and heart disease as the disease. And so here in this column it would be no heart disease. So if they had some other disease, in this case it would be okay, but it's just no heart disease. And then unexposed obviously is non-smoking. And so we took the people that are smoking and are smokers or have smoked and have heart disease, and they go in cell A. The people who are smoking but do not have heart disease are in cell B. The people who are non-smokers but have heart disease are in cell C, and the people who are non-smoking and do not have heart disease are in cell D. So now we'll just count up how many people we have in each of the cells, and then we're just going to add up the rows and columns. So it's always good to check your table. So we've got the rows, 7 total exposed, and then 13 total unexposed, and then those numbers add up to 20, which we know is our total population. And then we've got the 8 cases total of disease, and then 12 cases without the disease, or non-cases, and then those also add up to 20. So you always want to check your numbers to make sure they work. Okay, so we know that relative risk, which we learned in the last video, is the incidence in exposed over the incidence in unexposed. And so here's the formula for relative risk. So you can see here that the relative risk is A, which is this cell here, so those who were exposed and have the disease, over A plus B, which is the total number of exposed, and then all of that over C, which is the cases, people with the disease who are unexposed, over the total number of unexposed, which is C plus D. And so that is the incidence. This A over A plus B is the incidence in the exposed. C over C plus D is the incidence in unexposed. So just to calculate A over A plus B, so we've got A, the total cases, over the total, the cases among the exposed. So now we're just looking for the numerator, we're just looking at the people who are exposed. So that would be the cases over the total number of exposed, right? So that's 4 over 7, which equals 0.57, and then we'll do the same thing for the unexposed. So the unexposed C over C plus D is 4 over 13 equals 0.31, and then 0.57 divided by 0.31 equals 1.84. So that shows that that smoking increases risk of heart disease by 84%. Okay, so now that because it's over 1, that means that it's an increased risk, and then the 0.84 means that the increase is by 84%. Okay? So now we're going to look at another example, and here's our 2x2 table. We're not going to add the pictures this time. So again, we've got, we're looking at coronary heart disease as our outcome, our disease outcome, and then so the first column is the disease, people with the disease, the second column is people without the disease, and the first row is people with the exposure that we're looking at, and the second row is people that do not have the exposure that we're interested in. And so in this case, we're going to look at the relationship between being female and coronary heart disease. So our exposure in this case is female, and our unexposed group would be then male. So we've got 350 people in our population, and 150 of those people are female, so we're going to put them over here in the total female column, the total exposed column, and then 200 are male. Okay, and so we know that 3 of the females in our population that we followed for 20 years developed CHD. So we'll put those here. So those are the cases. And then we know that 8 of the males in our sample developed CHD. So we'll put that there. And so using the table, we can calculate the number of females who did not develop CHD, which is 147. And of course, that's just the total number of females minus the ones we know developed CHD, is 147 left who did not develop CHD. And so similarly, of the 200 men, we know that 8 developed CHD, so therefore we know that 192 did not develop CHD. And so now we can add up the columns just to make sure that we have calculated the numbers correctly. So 3 plus 8, we know we have 11 total cases in our sample of CHD, and therefore we know that we have 339 that did not develop CHD during the follow-up period. So here's our formula again for relative risk, and so we can just put in the numbers to this formula using the letters associated with the cells. Okay, so the first, the numerator is just the incidence in the exposed group, so we know that that is equal to A, which is 3, so it's just the number of cases in the exposed over the total number at risk in the exposed, which is A over A plus B, so 3 over 150. And then the incidence in the non-exposed is the number of cases, 8, for cell C, over the total number of at risk in the non-exposed, which is 200, C plus D. Okay, and then those 3 divided by 150 equals 0.02. 8 divided by 200 equals 0.04, and that equals 0.5. So 0.02 divided by 0.04 equals 0.5. And so we see there's a relative risk of 0.5 for being female and developing CHD. So the fact that the relative risk is below 1.0 means that the exposure is protective against the outcome of CHD. So that's because the incidence is lower in the exposed group versus the unexposed group, and specifically it's lower by 50%. So the 0.5 relative risk means that the exposed group is 50% less likely to develop the outcome than is the unexposed group. So when relative risks are under 1, that means that the exposure is protective. It decreases the risk of the outcome. When they're above 1, as we saw with smoking, that means that the exposure increases the risk of the outcome. And when the relative risk is 1, that means, of course, that the incidence is equal in the exposed and unexposed group. So that means that there is no relationship between the exposure and the outcome. So now you can try applying this to the new problems in the problem sets, and hopefully this is enough information to allow you to understand relative risk. So good luck.